ಶಿವಮೊಗ್ಗದಲ್ಲಿ ಶುಭಾರಂಭವಾಗಿದೆ. ಆಪ್ಟೆಕ್ ಮೋಟಾರ್ಸ್ ಅಂಡ್ ಆರ್ಯನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಮೋಟಾರ್ಸ್ ವಿನೂತನ ತಂತ್ರಜ್ಞಾನದ ಪರಿಸರ ಸ್ನೇಹಿ ಎಲೆಕ್ಟ್ರಿಕ್ ದ್ವಿಚಕ್ರ ವಾಹನಗಳ ಶೋರೂಮ್. ಪೆಟ್ರೋಲ್ ಹಂಗಿಲ್ಲದ ಸುಲಭ ಸವಾರಿಯ ಸುಂದರ ನೋಟದ ದ್ವಿಚಕ್ರ ವಾಹನಗಳ ಬೃಹತ್ ಸಂಗ್ರಹ. ಇಲ್ಲಿ ಸಿಗುತ್ತದೆ ಅತ್ಯಾಧುನಿಕ ಎಲ್ಮೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಸ್ಕೂಟರ್, ದೊಡ್ಡ ವೀಲ್ ಬೇಸ್, ಆಯಿಲ್ ಪುಲ್ಲಿಂಗ್ ಮೋಟಾರ್ ಹೊಂದಿರುವ ಗಟ್ಟಿಮುಟ್ಟಾದ ಕೇವಲ 8 ಸೆಕೆಂಡ್ನಲ್ಲಿ 60 ಕಿಲೋಮೀಟರ್ ಸ್ಪೀಡ್ ತಲುಪುವ ಎಲ್ಮೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಸ್ಕೂಟರ್ ಅನ್ನ ನಿಮ್ಮ ಅತ್ಯುತ್ತಮ ಸಂಗಾತಿಯಾಗಿಸಿಕೊಳ್ಳಿ. ಕೈಗೆಟಕುವ ದರದಲ್ಲಿ ಇಂದೇ ಒಂದು ಸ್ಕೂಟರ್ ನಿಮ್ಮದಾಗಿಸಿಕೊಳ್ಳಿ. ಪರಿಸರದ ಉಳಿವಿಗೆ, ಭವಿಷ್ಯದ ರಕ್ಷಣೆಗೆ ನಮ್ಮದೊಂದು ಕೊಡುಗೆ ನೀಡಿ. ಭೇಟಿ ನೀಡಿ ಆಪ್ಟೆಕ್ ಮೋಟಾರ್ಸ್ ಅಂಡ್ ಆರ್ಯನ್ ಮೋಟಾರ್ಸ್, ಶಿಬಾ ಕಾಂಪ್ಲೆಕ್ಸ್, ಜೈಲ್ ರಸ್ತೆ, ಶಿವಮೊಗ್ಗ. ಸಂಪರ್ಕಿಸಿ 900-888-5063 ಅಥವಾ 8296-892205.
ಹೋಟೆಲ್ ಚಾರ್ವಿ ಮೀನಿನ ಅಂಗಡಿ ಮತ್ತು ವೆಜ್ ನಾನ್ ವೆಜ್ ರೆಸ್ಟೋರೆಂಟ್. ಸಕ್ಕರ್ ಟೇಸ್ಟ್, ತರೇವಾರಿ ಖಾದ್ಯಗಳು, ಬಾಯಲ್ಲಿ ನೀರೂರಿಸುವ ಮೀನಿನ ಊಟ, ಪಕ್ಕ ಫ್ಯಾಮಿಲಿ ರೆಸ್ಟೋರೆಂಟ್ ಇದೀಗ ಶುಭಾರಂಭಗೊಂಡಿದೆ. ಹಿಂದೆ ಕುಟುಂಬ ಸಮೇತರಾಗಿ ಭೇಟಿ ನೀಡಿ ಬಗೆ ಬಗೆಯ ಖಾದ್ಯಗಳನ್ನ ಸವಿಯೋದನ್ನ ಮರೆಯದಿರಿ. ಸ್ಥಳ BH ರಸ್ತೆ, ವಿದ್ಯಾನಗರ, ಶಿವಮೊಗ್ಗ. ಹೆಚ್ಚಿನ ಮಾಹಿತಿಗಾಗಿ ಸಂಪರ್ಕಿಸಿ 9483309122.
ಇದೇ ಮೊದಲ ಬಾರಿಗೆ ಶಿವಮೊಗ್ಗದಲ್ಲಿ ಒಂದೇ ಸೂರಿನಡಿಯಲ್ಲಿ ಸಕ್ಕರೆ ಕಾಯಿಲೆಗೆ ಸಂಬಂಧಪಟ್ಟಂತೆ ಎಲ್ಲಾ ವೈದ್ಯಕೀಯ ಪದ್ಧತಿಗಳ ಸಮಾಗಮವನ್ನು ನಾವು ಏರ್ಪಡಿಸಿರ್ತೀವಿ. ಇದೊಂದು ಮಧುಮೇಹದ ಜನಜಾಗೃತಿ ಸಮಾವೇಶ. ಸಕ್ಕರೆ ಕಾಯಿಲೆ ಬಗ್ಗೆ ಬಲ್ಲವನು ಸಕ್ಕರೆ ಕಾಯಿನ ಖಂಡಿತವಾಗೂ ಗೆಲ್ತಾನೆ, ಸಕ್ಕರೆ ಕಾಯಿಲೆ ಗೆದ್ರೆ ಜೀವನವನ್ನು ಖಂಡಿತವಾಗಿ ಗೆಲ್ಲುತ್ತಾನೆ. ಈ ಕಾಯಿಲೆ ಒಂಥರ ಸೈಲೆಂಟ್ ಕಿಲ್ಲರ್ ತರ. ಇದು ಸ್ಟ್ರೋಕ್ ಮಾಡ್ಬೋದು, ಹಾರ್ಟ್ ಅಟ್ಯಾಕ್ ಮಾಡ್ಬೋದು, ಕಿಡ್ನಿ ತೊಂದರೆ ಮಾಡ್ಬೋದು, ಕಾಲಿನ ಗ್ಯಾಂಗ್ರೀನ್ ಮಾಡ್ಬೋದು, ಮತ್ತೆ ಕಣ್ಣಿಗೆ ಕೂಡ ತೊಂದರೆ ಕೊಡ್ಬೋದು. ಈ ಕಾಯಿಲೆ ಬಗ್ಗೆ ವೈದ್ಯರಿಗೆ ಎಷ್ಟು ತಿಳಿದಿರುತ್ತೋ ಅಷ್ಟು ಮಟ್ಟಿಗೆ ಪೇಷಂಟ್ ಮತ್ತು ಅವರ ಫ್ಯಾಮಿಲಿಗೆ ತಿಳಿದಿರಬೇಕಾದ ಅಗತ್ಯತೆ ಇದೆ. ಸೊ ಈ ಕಾಯಿಲೆನ ನಾವು ತಿಳ್ಕೊಂಡ್ರೆ ಮಾತ್ರ ಇದನ್ನ ಕಂಟ್ರೋಲ್ ಮಾಡ್ಬೋದು. ಹಾಗಾಗಿ ಸಕ್ಕರೆ ಕಾಯಿಲೆ ಬಗ್ಗೆ ಬಲ್ಲವನು ಸಕ್ಕರೆ ಕಾಯಿಲೆಯನ್ನ ಗೆಲ್ಲುವನು. ಸಕ್ಕರೆ ಕಾಯಿಲೆ ಗೆದ್ರೆ ಮಾತ್ರ ನಮ್ಮ ಜೀವನನ ಗೆಲ್ಲೋದಕ್ಕೆ ಸಾಧ್ಯ. ಈ ನಿಟ್ಟಿನಲ್ಲಿ ನಾವು ಇದೇ ಅಕ್ಟೋಬರ್ 16 ಭಾನುವಾರ ಕುವೆಂಪು ರಂಗಮಂದಿರದಲ್ಲಿ ವಿನ್ ಲೈಫ್ ಟ್ರಸ್ಟ್ ವತಿಯಿಂದ ಸಕ್ಕರೆ ಕಾಯಿಲೆಗೆ ಸಂಬಂಧಪಟ್ಟಂತೆ ಈ ಎಲ್ಲ ವೈದ್ಯಕೀಯ ಪದ್ಧತಿಗಳ ಸಂವಾದ ಮತ್ತೆ ಪ್ರಾತ್ಯಕ್ಷಿಕೆ ಮತ್ತು ಅದರ ಬಗ್ಗೆ ಚರ್ಚೆನ ನಾವು ಏರ್ಪಡಿಸಿದ್ದೇವೆ. ಅಕ್ಟೋಬರ್ 16ರಂದು ಆಯುರ್ವೇದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಂತೆ ಆಹಾರ ವಿಧಾನಗಳು ಹೇಗಿರ್ತವೆ, ಸಕ್ಕರೆ ಕಾಯಿಲೆಗೆ ಯೋಗಾಭ್ಯಾಸ, ಸಕ್ಕರೆ ಕಾಯಿಲೆಗೆ ಸಂಬಂಧಿಸಿದಂತೆ ಪ್ರತ್ಯೇಕ ಯೋಗಾಭ್ಯಾಸ ಏನಿರುತ್ತೆ, ಹಾಗೆಯೇ ಆಧುನಿಕ ವೈದ್ಯಕೀಯ ಪದ್ಧತಿಯಲ್ಲಿ ಸಕ್ಕರೆ ಕಾಯಿಲೆಗೆ ಯಾವ ತರ ಚಿಕಿತ್ಸೆ ಇರುತ್ತೆ, ಇದರ ಬಗ್ಗೆ ಒಂದು ಸಂವಾದ, ಚರ್ಚೆ ಮತ್ತು ವಸ್ತು ಪ್ರದರ್ಶನ. ಅಂದ್ರೆ ಇನ್ಸುಲಿನ್ ಅಲ್ಲೇ ಆಧುನಿಕ ಇನ್ಸುಲಿನ್ ಅಂದ್ರೆ ಏನು, ಯಾವ ತರ ಬಂದಿದೆ, ನೋವು ರಹಿತ ಇನ್ಸುಲಿನ್ ಅಂದ್ರೆ ಏನು, ನೋವು ರಹಿತವಾಗಿ ಸಕ್ಕರೆನ ಪರೀಕ್ಷೆ ಮಾಡೋದು ಹೇಗೆ, ಪಾದಗಳ ಆರೈಕೆ ಮತ್ತು ಅದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಂತ ಆಧುನಿಕ ಚಪ್ಪಲಿಗಳ ಪ್ರದರ್ಶನ, ಕಣ್ಣುಗಳ ಆರೈಕೆ ಮತ್ತು ಅದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಂತೆ ಆಧುನಿಕ ವಸ್ತುಗಳ ಪ್ರದರ್ಶನ. ಅಕ್ಟೋಬರ್ 16ನೇ ತಾರೀಕು ಭಾನುವಾರ ಬೆಳಿಗ್ಗೆ 9 ಗಂಟೆಯಿಂದ ಕುವೆಂಪು ರಂಗಮಂದಿರದಲ್ಲಿ ಮಧುಮೇಹದೊಂದಿಗೆ ಸುಗಮವಾಗಿ ಬಾಳುವ ಪಯಣದಲ್ಲಿ ಎಲ್ಲರನ್ನೂ ಕರೆತನ್ನಿ, ಇದರ ಸದುಪಯೋಗವನ್ನು ಪಡೆದುಕೊಳ್ಳಿ. ವಿನ್ ಲೈಫ್ ಟ್ರಸ್ಟ್ ವತಿಯಿಂದ ಏರ್ಪಡಿಸಿರುವ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ದಯವಿಟ್ಟು ಬನ್ನಿ.
ಈಗಲೇ ಪ್ಲೇಸ್ಟೋರ್ನಲ್ಲಿ ಆಪ್ ಡೌನ್ಲೋಡ್ ಮಾಡಿ ಕುಳಿತಲ್ಲೇ ಕನ್ನಡ ಮೀಡಿಯಂ 24x7 ನೋಡಿ. ರಾಷ್ಟ್ರ, ರಾಜ್ಯ, ಜಿಲ್ಲೆಯ ಸುದ್ದಿಗಳು ಒಂದೇ ಸೂರಿನಡಿ. ಆಪ್ ಡೌನ್ಲೋಡ್ ಮಾಡಿ ಉಚಿತ ಸುದ್ದಿ ನೋಡಿ.
ಇವತ್ತು ನಾವೆಲ್ಲರೂ ಕೇಳ್ಕೊಳ್ಳೋದು ಒಂದೇ, ಒಳ್ಳೆ ಆರೋಗ್ಯ. ಇವತ್ತಿನ ಲೈಫ್ ಸ್ಟೈಲ್ ನಲ್ಲಿ, ಇವತ್ತಿನ ಫುಡ್ ಹ್ಯಾಬಿಟ್ಸ್ ನಲ್ಲಿ, ಇವತ್ತಿನ ಪ್ರೆಸೆಂಟ್ ಸಿಚುವೇಶನ್ ಅದು ಸಾಧ್ಯ ಅಲ್ಲ. ಅಮೃತೋನಿ ಪಾಪ್ಲಸ್ ಇದ್ರೆ ಅದು ಖಂಡಿತ ಸಾಧ್ಯ. 10 ವರ್ಷಗಳಿಂದ ನನ್ನ ಇಮ್ಯುನಿಟಿಗೆ, ನನ್ನ ಎನರ್ಜಿಗೆ ಜೊತೆಯಾಗಿರೋದು ಅಮೃತೋನಿ ಪಾಪ್ಲಸ್. ನೆನಪಿಡಿ, ಎಲ್ಲಾ ನೋನಿ ಅಮೃತೋನಿ ಅಲ್ಲ. ಆರೋಗ್ಯದ ಭರವಸೆ ಅಮೃತೋನಿ ಪಾಪ್ಲಸ್.
Show your love. Gift Nandini Sweets. ನಿಮ್ಮ ಪ್ರೀತಿಯಷ್ಟೇ ಶುದ್ಧ.
ನಂದಿನಿ ಮಿಲ್ಕ್ ಅಂಡ್ ಪ್ರಾಡಕ್ಟ್ಸ್, ನ್ಯಾಚುರಲಿ ನ್ಯೂಟ್ರಿಷಿಯಸ್.
ಪಿಜಾ ಸಿಲ್ಕ್ಸ್ ಅವರಿಂದ ನಾಡಿನ ಸಮಸ್ತ ಜನತೆಗೆ ದೀಪಾವಳಿ ಹಬ್ಬದ ಶುಭಾಶಯಗಳು. ನಮ್ಮಲ್ಲಿ ವಿವಿಧ ಬಗೆಯ ಸೀರೆಗಳಾದ ಫ್ಯಾನ್ಸಿ, ಸಾಫ್ಟ್ ಬನಾರಸ್, ಸಾಫ್ಟ್ ಸಿಲ್ಕ್ ಮತ್ತು ಪ್ಯೂರ್ ಸಿಲ್ಕ್ ಸ್ಯಾರಿಗಳು ಲಭಿಸುತ್ತವೆ. ಡ್ರೆಸ್, ಚೂಡಿದಾರಗಳು ಹಾಗೂ ಪುರುಷರಿಗಾಗಿ ಪಂಚೆ, ಬನಿಯಾನ್, ಶಾಲ್, ಟವೆಲ್ ಇತ್ಯಾದಿಗಳು ಯೋಗ್ಯ ದರದಲ್ಲಿ ಲಭಿಸುತ್ತವೆ. ಆತ್ಮೀಯ ಗ್ರಾಹಕರೇ ಮತ್ತು ಸಹೋದರ ಸಹೋದರಿಯರೇ, ದೀಪಾವಳಿ ಪ್ರಯುಕ್ತ ಪಿಜಾ ಸಿಲ್ಕ್ಸ್ ವತಿಯಿಂದ ವಿಶೇಷ ಕೊಡುಗೆ ನಿಮಗಾಗಿ. ನಮ್ಮಲ್ಲಿ 2500 ರೂಪಾಯಿಯ ಪ್ರತಿ ಖರೀದಿಗೆ ಒಂದು ಗಿಫ್ಟ್ ಹ್ಯಾಂಪರ್ ನೀಡಲಾಗುವುದು. ಇದು ಸೀಮಿತ ಅವಧಿಯ ವಿಶೇಷ ಕೊಡುಗೆಯಾಗಿದೆ. ಈಗಲೇ ನಿಮ್ಮ ಪರಿವಾರ, ಬಂಧು ಮಿತ್ರರೊಂದಿಗೆ ಆಗಮಿಸಿ ನಿಮಗೆ ಬೇಕಾದ ಬಟ್ಟೆ ಖರೀದಿಸಿ ಗಿಫ್ಟ್ ಅನ್ನ ನಿಮ್ಮದಾಗಿಸಿಕೊಳ್ಳಿ. ಹಿಂದೆ ಸಂಪರ್ಕಿಸಿ ಪಿಜಾ ಸಿಲ್ಕ್ಸ್, ಗಾಂಧಿ ಬಜಾರ್ ಪಕ್ಕ, ಕುಚಲಕ್ಕಿ, ಬಿಎಚ್ ರಸ್ತೆ ಕ್ರಾಸ್, ಶಿವಮೊಗ್ಗ. ನಮ್ಮ ದೂರವಾಣಿ ಸಂಖ್ಯೆ 8722139464.
ನಂದನೆ power packed milk.
ನಂದಿನಿ ಮಿಲ್ಕ್ ಅಂಡ್ ಪ್ರಾಡಕ್ಟ್ಸ್, ನ್ಯಾಚುರಲಿ ನ್ಯೂಟ್ರಿಷಿಯಸ್.
I feel privileged to extend my warm welcome to all presented here for an international seminar on termites and root grubs. I request all of you to kindly switch your mobile phones to silent mode. Thank you for your kind cooperation. I take this privilege to warmly welcome all the distinguished guests, invited speakers and delegates to this wonderful international seminar on termites and root grubs, organized by Department of Entomology, College of Agriculture, Shivamogga, in collaboration with National Agricultural Higher Education Project, New Delhi, and Ministry of Environment, Forest and Climate Change, New Delhi, for extending their valuable support to us. As Mother Teresa said, prayer is not asking, prayer is putting oneself in the hands of God. Before start of any program, as a tradition to seek the blessings of the God, I invite Miss Ananya for invocation song.
ಗಣಪತಿಯೇ ಬುದ್ಧಿದಾತನೇ ಸಿದ್ಧಿನಾಥನೇ ಸಲಹು ಗಣೇಶನೇ ವಿದ್ಯಾಧಿಪನೇ ನೀ ನಮ್ಮ ಗೆಲುವಾಗಿ ಬಾ ಗಜಮುಖನೇ ನೀ ನಮ್ಮ ಗೆಲುವಾಗಿ ಬಾ ನೀ ನಮ್ಮ ಗೆಲುವಾಗಿ ಬಾ ಗಜಮುಖನೇ ನೀ ನಮ್ಮ ಗೆಲುವಾಗಿ ಬಾ ಗುರುಕುಲಕ್ಕೆ ವರವಾಗಿ ಗುರಿತೋರೋ ಗುರುವಾಗಿ ವರ ನೀನು ಎಂದೆಂದು ಕರುಣಾಳು ಬಾ ಬಂದು ನೀ ನಮ್ಮ ಗೆಲುವಾಗಿ ಬಾ ಗಜಮುಖನೇ ನೀ ನಮ್ಮ ಗೆಲುವಾಗಿ ಬಾ ಬಾಳಲ್ಲಿ ಒಂದಾಗಿ ಬಾ ನಮ್ಮ ಜೊತೆಯಾಗಿ ಕ್ಷಣ ಕ್ಷಣವು ನಮಗಾಗಿ ನೆರವಾಗು ಬೆಳಕಾಗಿ ದಯಿರಲಿ ನಮ್ಮಲ್ಲಿ ಗತಿ ನೀನೆ ಆದಿಯಲಿ ನೀ ನಮ್ಮ ಗೆಲುವಾಗಿ ಬಾ ಗಜಮುಖನೇ ನೀ ನಮ್ಮ ಗೆಲುವಾಗಿ ಬಾ ನಿಧಿಯಾಗಿ ವಿಧಿಯಾಗಿ ಸುದೆ ತುಂಬು ಬಲವಾಗಿ ಹಿರಿಯಾದ ಸಿರಿ ನೀನು ಈ ಬಾಳ ಸವಿಜೇನು ದಯೆ ಇರಲಿ ನಮ್ಮಲ್ಲಿ ಗತಿ ನೀನೆ ಆದಿಯಲಿ ನೀ ನಮ್ಮ ಗೆಲುವಾಗಿ ಬಾ ಗಜಮುಖನೇ ನೀ ನಮ್ಮ ಗೆಲುವಾಗಿ ಬಾ ನೀ ನಮ್ಮ ಗೆಲುವಾಗಿ ಬಾ ನೀ ನಮ್ಮ ಗೆಲುವಾಗಿ ಬಾ. ಥ್ಯಾಂಕ್ ಯು.
Thank you, Ms. Ananya, for your melodious invocation song. Now I invite our Professor and Head, Department of Entomology, Dr. Jayalakshmi Narayan Hegde, Madam, to deliver the welcome address. Please, Madam.
Good morning to one and all. Respected dignitaries on the dais and invited speakers from different parts of Karnataka and different states and outside the country, and entomologists from different parts of Karnataka and outside the state, and fellow participants, and all the teaching and non-teaching staffs, and dear students. And today, our Department of Entomology, College of Agriculture, Shivamogga, is organizing international seminar on termites and white grubs. I am very much pleased that KSN UAHS Shivamogga's first international seminar, the today's seminar. This is very much pleased because our Department of Entomology is organizing the first international seminar. And for this occasion, it is my pleasure to welcome one and all gathered over here. At the outset, I would like to welcome our dynamic, beloved, Honorable Vice Chancellor, Dr. R.C. Jagdish, who is helping our all the activities every day, and for smooth conduct of this international seminar also, from last 1 month he is helping. Sir, on behalf of all the participants, I extend a warm welcome, sir. Today's chief guest, Dr. S.N. Sushil, Director, ICAR, National Bureau of Agricultural Insect Resources, Bangalore. In spite of his busy schedule from Bangalore all the way, he travelled and he is on time for our international seminar. Sir, I am very much pleased that most of our students are attached to your institute for our taxonomic work, molecular work and other work, sir. Sir, on behalf of Keladi Shivappa Agriculture, University of Agriculture and Horticultural Sciences, and on behalf of all the participants, a warm welcome to you, sir. Another chief guest of our university, Dr. M. Hanumantappa, Director of Education, KSN UAHS. Activities, of course, for this seminar also, he has helped in different ways. Sir, on behalf of all of us, I will welcome you for College of Agriculture, Irvaki Campus, Shivamogga. He also has come and he is helping this international seminar through IDP program. Sir, on behalf of all, I welcome you, sir. And most important part of today's seminar, the invited speakers. Invited speakers from different parts of Karnataka, even state and even outside the country also, you have arrived on time for delivering different technical information. At the outset, I would like to invite Dr. Kolla Sridevi, Principal Scientist, ICR, NVR, Bangalore. And second speaker, Dr. Kalleswar Swami, who is the leader and organizing secretary of this particular seminar. I welcome you, sir. And Dr. Taisuke Kanar, Assistant Professor, Yamagata University, Japan. He is here on behalf of Keladi Shivappa University of Agriculture and Horticulture, Shivamogga, and on behalf of all the participants, I welcome you, sir. And Dr. Amina Puvali, Assistant Professor, Sir Syed College, Tirupurama, Kerala. She is here and she is giving information on termites and white grub. I welcome you, sir. Madam. And Dr. Rashmi A.R. Shanbag, Scientist, Indian Plywood and Industrial Research Organization, Bangalore. She is also one of the lead speakers. Madam, on behalf of our university and all the participants, I welcome you. Mr. D. Iyengar, Plant Protection Officer, DPPQS, Faridabad. In spite of his busy schedule, he has arrived to this program as an invited speaker. On behalf of our university and on behalf of all of us, I welcome you, sir. Dr. Prakash Kevi, Associate Professor, Entomology, University of Agricultural Sciences, GKBK, Bangalore. He has also arrived to give a valuable information on white grub. I welcome you on behalf of our university and all the participants. Mr. Ishanya Sharma, KR, Wildlife Photographer Sagara, yet to be read because he is on the way. In his absence, I welcome him also. And all of us, we are eagerly waiting for our technical session. I think all the 8 lead speakers are giving very valuable information, which will be a very asset for our Department of Entomology and entomologists. And I would like to welcome our senior entomologists from different parts of Karnataka, Dr. Shivamogga sir, and other entomologists from Raichur, Dharwad, Bangalore, and Bagalkot also. On behalf of our university, a warm welcome you all. And our fellow entomologists from different campuses of UKS and UAHS Shivamogga have arrived on time for this international seminar. I welcome you all for today's international seminar. And different professionals from Bangalore, Dharwad, Raichur, Bagalkot, and even outside the Karnataka also have arrived. I hope this message of this international seminar will help you for your research. I welcome you all for this international seminar. And last but very important, our student participants from different parts, all are eagerly waiting for this technical session. I welcome you all for this international seminar, and I hope you will carry a very good message and you will implement most of the. And I also welcome our faculty members, teaching and non-teaching staff of this campus for this international seminar. From last 1 week, they are helping to conduct this in a very smooth.
Working on scarab biodiversity. So with the last 15 years of experience, Madam has actually described more than 25 new species of scarabs, and at the same time, she is actually traveling throughout India, especially Himalayas, even Northeast India, and collecting the scarabs and describing new species. And she is a diehard fan of and describing new species. And she is a diehard fan of
my views and also ideas on this carafanal diversity. So I'm privileged to present a small piece of information on white grubs in presence of Sushil sir, who has done extensively in white grubs when he was in Almora, and also when he was in IAS Lucknow. So students and colleagues, I'll be just briefly presenting because of the paucity of time from the morning. We wanted to have a more elaborate technical session. So I'll be skipping the introduction. because all of you now aware, because from morning we are deliberating that these two termites and white grubs are the soil dwelling insects and are important components of soil biota, and we have the beneficial group of these insects as well the harmful groups also. So as beneficial groups, they are very rich components of soil and they are integral part of it, where they improve the structure and fertility of the soil by nutrient recycling and also decomposing, regulating, giving extra supporting and regulating services, and also serving as a good bioindicators. So these white grubs belong to Scarabidae, and also the beneficial part, as I was telling, dung rollers, they also belong to Scarabidae. So the Scarafauna belongs to Scarabidae family of superfamily Scaraboidea under Coleoptera. So all of us know that Coleoptera is the largest group, and the Scarabidae is again the largest family, which comprises of rich diverse fauna. And this just for the benefit of students, we have more diagnostic characters, but just to pinpoint, it is the lamellate antennae and four-dentate tibia that differentiates this group of insects from the other beetles of Coleoptera. Okay, so coming to the diversity, we have nearly 30,000 species, as rightly expressed by our beloved director in the inaugural address, across the country, across the world, and it comprises of the Scaraboidea, which mainly compose of three major families, Lucanidae, Passalidae and Scarabidae, of which 91% is occupied by Scarabid group. And these scarabids have both coprophagous and phytophagous, I was rightly expressing from the first slide. So the phytophagous group is the again largest group in this particular Scarabidae family, where it comprises of 25,000 species. So this is the phytophagous group and coprophagous group. Under coprophagous, we have major two subfamilies, the Aphrodinae and Scarabinae, where it comprises of dung rollers. And the phytophagous have four subfamilies, the Melanthinae, Rutulinae, Danastinae and Cetoninae, which popularly we talk about white grubs belong to subfamilies Melanthinae, Rutulinae and partly Danastinae. Not all Danastines are white grubs, but all Melanthines and Rutulines are white grubs. And you all know that white grub is of national importance and how much damage it is going to cause. I'll be explaining in further coming slides. So coming to the coprophagous, just I would like to brief the beneficial part of it also, because always when we talk about insects, we had to talk about the beneficial also, harmful also. So both conservation and management, both has to go hand in hand. So when there is a beneficial part of it, we need to go for the conservation. So because of that, because why I am stressing upon this group is, when I visit field, as Dr. Kaleshwar Swami has told, my passion is to travel a lot. So when I visit so many farmers field, they used to bring larvae, and they used to tell, madam, ye to nuksan kar raha hai hamara fasal ko. So that comprises of even non-phytophagous forms. So they are confused with phytophagous forms, and they are dung rollers, and they can be cetonines also, which are humus feeders. So they get confused with that, and they tell that we want to dump the chemical insecticides. So in that direction also we need to educate them, and for you also I thought I'll just give a brief introduction of this, where we have 7,000 species across the world and 700 in our country. And these dung beetles, we all know they decompose and nutrient recycling, everything is there. In that, based on the functional activity, they are grouped into endocoprids and telecoprids and also paracoprids. So based on the activity, see some are rollers. As soon as they see the dung beetles, they just carry the dung ball. They make it into a ball and then they just roll it away. And certain dung beetle species, what they do is, they just make a tunnel underneath the dung bat. Underneath the dung bat, they make a tunnel, and to the tunnel they just go to the end of the tunnel and they brood. Actually, why they make dung ball is for their larva to thrive in that. So that's how they offer this dung as a food to their offsprings. In the process, they are decomposing the feces. And imagine if these feces are not decomposed. We will be with filth all around. So that important are the dung beetles. So this is just an example. So I was just mentioning the same thing. In absence of dung beetles, it will be all fouling smell, parasitic flies will be developing, and there will be no proper disintegration, and there will be no grazing pastures for the cattle as well. And so that is the importance of this one. And as I told, as a part of the offering dung as a food, they are decomposing, disintegrating, and thereby improving the nutrients of the soil also. And one scientist has observed that 4,000 dung beetles will immediately come to the dung as soon as it pats onto the soil within 15 minutes. And within half an hour, 12,000 dung beetles will join. See the diversity. So that we need to encourage and we need to conserve. So here briefly, I don't know how many of you know the Australia example of dung beetles? Any students? Yeah, I'm glad one is knowing. Actually in Australia what happened is, Australia, which is the national animal? Kangaroo. Kangaroo's feces is very hard, dry. So the scarab beetles are there. The scarab fauna that is present, that is occurring in Australia, are used to those hard, dry pellet form of feces to disintegrate. And the European settlers in 1880, they have gone for the cattle farming. And when cattle has been imported and then they started cattle farming and all, the wet dung has come into the place, and the kangaroo's feces decomposing beetles do not know how to decompose the wet dung because they are used to the hard dung. So that's how the dung has piled up in Australia, and it has been given a big threat and havoc to the cattle, to the pastures, and to the human life because of the foul smell, everything. Then Dr. Bornemisza in 1965 to 1985, he has been given the mission of working out the solution for this decomposing of wet dung by the cattle, and he has taken Pretoria as his unit, because when we introduce any insect, let it be predator, let it be parasite, or let it be any insect, we have to be very careful that the associated organisms will not introduce in it. So they have taken Pretoria in South Africa as a station for working out the solution, and then they have imported certain dung beetles, especially the Anthophagous species, and then they have multiplied there. Then they released into Australia, and they have taken care of the wet dung. So that is the importance of dung beetles. So we need to look around, and then we need to conserve. I am actually not working on dung beetles right now. In future I may take it up, that group, but right now I am working on white grubs because we all know that they are serious pests, and the diversity is huge and enormous than the dung beetles. So as I have told, these two predominantly belong to two subfamilies, Melanthini and Rutellinae, and we have these tribes, Melanthini, Sericini, Diplotaxini, Anomolini, Rutellinae, and Adoratini. Of course, Rutellinae is not present in our country. The other tribes are occurring here. So this is the brief species diversity. For anything, for taxonomic descriptions also, and for management point of view also, we need to have an account of diversity of a particular fauna. So for that we need to have an estimate. So these are all earlier estimates that have been given by the earlier workers. So these white grubs, we all know that they are serious pests of several crops, and they are expanding their host range. And now the most affected crops are sugarcane, groundnut, potato, arecanut, and soybean. And in any case, if we have a modest 10% loss due to these white grubs also, it is amounting to 23 to 24,000 per hectare. So sugarcane, if we take, the area under cultivation is 5 million hectares, and the production is 370 to 390 million tons, and the yield loss, I have calculated on basis of only 10%. But we all know that the losses may range from 40 to 90%. I have seen in western Uttar Pradesh, one Jakwala area and all, where the farmers have abandoned their sugarcane crops because of these white grubs. If we pull out one clump of the sugarcane, we will find 9 to 10 in one clump. So that is the severity, and farmers are fed up with these white grubs in certain endemic areas. Same is the case in groundnut. So 5.85 million hectares, the loss will amount to 1.33 crores. So we need to understand the diversity and the predominant species and its distribution for developing the management strategies. So this is the potato that is occurring. So why I am stressing upon the faunal diversity is, from the faunal diversity studies, we can come to the species richness, predominance, and also the other biogeographical analysis, phylogenetic analysis, and also the distribution pathway. In that map, I have given 3 arrows, 3 rows, because when I was in IRI, I have taken up extensive touring and surveys in northern states, that Himachal Pradesh, Uttarakhand, Uttar Pradesh and Rajasthan, and also northeast states, Assam, Meghalaya, Tripura, Mizoram, and also little bit of Arunachal Pradesh. Only 2 states which I have not covered properly are Manipur and Sikkim, which I am targeting now in forthcoming years. There what I would, and now after coming to NBIR, I am concentrating on South Indian states, Kerala, Tamil Nadu, Karnataka and Maharashtra. So here, when I have taken up surveys for last 5 years, I have joined NBIR in 2017. From then onwards, I am surveying these 5 states. My collections have showed that, I think pointer is not working. The blue arrow marks is one species. It's okay, sir. No problem, sir. Blue marks is one species, and red arrow marks are another species, where the species range is explained. So the same species, I got it in from Kerala to Karnataka, further to Uttar Kannada, and from Tamil Nadu to Karnataka to Andhra Pradesh. So here the central round patch which I have given is of one Anomola communis species, which is very conserved in that area only. I am not finding it in other areas. It is found in very abundant numbers in parts of Kerala and in Ooty region, which has been described and explained by Dr. Arrow in 1905. So even after 100 years, that particular species is conserved in that area only. So it can be described as a hotspot area for that particular species and endemic area. So both the things are present. That only I would like to stress upon. And why diversity studies are important means, we know the new species or the evolutionary traits developed by the diversity only, and also insects are successful because of the number of adaptations and also the diversity. So the greater the biodiversity, we know that greater community stability will be there, and also we need to, of course, from the pest point of view, pestiferous nature, we can zero upon the most predominant species, but it is equally important for a taxonomist to nail upon the rare species also, because rare species are the strong indicators, and also they exert strong influence on the ecosystem functioning. So this is one study which I have taken up when I was in IRI. That's what I was telling. If we see the diversity of 4 states, it is very different, and I'll be in next slide, I'll be showing the niche partitioning also, the species composition, and the predominant species is also different. So that's how I think, that's why white grub is very, very difficult to manage, very tough pest. By and large, melalanthin is the abundance one. I have told that two subfamilies are there, Melanthine and Rutalinae. Melanthine is the abundant across the several locations and also crops. But in forest areas, Rutalinae is the abundant one. So this is the one which I am telling, the niche partitioning. So if we see the Himachal Pradesh and Uttarakhand, by and large the species distribution is but for one or two species, it is little uniform. But if you take Rajasthan, the 50% area is occupied by Holotricha consanguinea, which is the major pest of groundnut over there. And three species, the Holotricha consanguinea, Maladara insanibellis, which is in brown color, and the Anomalia dimidiata, which is in green color. These three comprises of 70 to 75% of the fauna. So here the dominance of three species is more. So such interpretations will help us or aid us in strategizing the management options. Similarly in Uttar Pradesh, only 5 species scoop out 80% of the particular niche. So when we go for the Whittaker rank abundance curve and also Preston's log abundance matrix, it also indicates that the common species are very few. That is the rule for any community. Actually, if we take any community, the common species will be less and the rare species will be more. So is the case in white grubs also. And as the rare species are more, the ecosystem functioning will be higher. And this is the theory that has been put forth, agent area and size and space. So if the size is more, it occupies the more niche, and if it is a old one which has intruded into that place earlier, it will scoop out the larger portion of the niche. So this is another study in Western UP where I have concentrated from Bulandshahr to Amroha district to Ghaziabad, Meerut, and then Muzaffarnagar to Saharanpur. So when I have gone for surveys for continuous 3 years, I can see the distinct predominance is different. It's not, see, Western UP is a small portion. So it can be as well, it's a sugarcane crop only. I have surveyed in sugarcane crop ecosystem only, and it can be Holotricha serrata only across the districts, but it is Nagpurensis in Amroha, and it is consanguinea in Saharanpur. And in between it is a mix of serrata and Nagpurensis, but serrata is more in Ghaziabad and Muzaffarnagar. And one species, Lepidiota manciota, it's a very interesting one which completes in 2 years, and it is very endemic in Majoli Island in Assam. It is a big, major pest of sugarcane crop. That is occurring in only Amroha region. That and all we need to, what is the reasons or factors behind the colonization we need to analyze. So nowhere else I could find this Lepidiota manciota but for in Amroha district in particular village. So this is white grub fauna across the agroclimatic zones of Maharashtra. And if we analyze the scarab species diversity for the last 5 years, 2012 to 2017, the major scarab species which I have plotted, that is Holotricha serrata, Holotricha consanguinea, Anomalia dimidiata, Anomalia bengalensis, and Philognathus dionysius in northern states. You can see others are okay, they are just dwindling, but you can just check the Philognathus dionysius, the last bar, blue, it is constantly increasing. And so is the case in South Indian states also. Here in Dharwad, in several parts of Karnataka, Tamil Nadu, Andhra Pradesh, Philognathus dionysius, which belongs to dynastin group, is becoming very, very predominant and very dominant in most of the crops, even in turmeric, ginger, soybean, like that. So it has been, and it is not that it has suddenly cropped up now. It has been mentioned in Maxwell Lefroy's book in 1901 in Indian Insect Life. That time also he has mentioned Philognathus dionysius as a pest of rice crop, and still it is existing. In between, I don't know, other species would have taken the upper hand. Now it is again surging up. So another point where the diversity faunal studies will yield is the color morphs. So this is only one species, Anomalia dorsalis, and it is predominant in sugarcane ecosystem also, groundnut ecosystem also, and in one particular area I could get these 7 color morphs. So the color morphs whether they are potential to become a new species or whether these are the color variations within the species, that we are analyzing and studying now. So with the diversity studies, we can just plot the endemic areas like this, and then species distribution in Karnataka, where Naveen from this university only has taken up this study and submitted as a doctoral degree in this university. So he has come out with nearly 70 plus species of Phytophagous scarabs only, and then this is the distribution that he has found. Here the two major points, there is an overlap of species in the across the districts from south to north Karnataka, but two species I would like to take your attention. One is Anomalia illusa and another is Brahmina mysorensis. So Anomalia illusa is found only, which is very similar to Anomalia elata. And in scarabs, another challenge is that several species look morphologically similar, very similar, and we need to look for the very specific diagnostic characters to distinguish the species. So Anomalia illusa, which can be confused with Anomalia elata, is occurring only in Uttarakhand, and it's a new record to the country. So Naveen has to publish. I don't know where is Naveen. You have to publish, okay? Here's not your publication. So this is a new record to the country, and then Brahmina mysorensis, which is in Shivamogga, that is also concentrating only in present in only in Shivamogga, not in other areas. So such what I can say, documentation we will get, and also database generation will be done with the scarab faunal diversity studies. And this is another thing which I was telling, they look similar. It is the Anomalia bengalensis complex, where all these look very similar. Anomalia bengalensis, elata, illusa, polyta, bilobeta and anguliceps. And this is the distribution that I have given here. I'll be leaving my presentation here, so you can just check. Just I would like to highlight the importance of the scarab faunal diversity, how rich it is and how diverse it is, and why the diversity studies are important. So this is the one which I was telling, Anomalia communis, which is century-long existence and endemism in Ooty, and also little parts of certain parts of Karnataka, Tamil Nadu, and then Kerala. So in last 5 years, a little bit of my work which I have done. So all these states which I have surveyed, I am not presenting the species documentation. Species documentation is again there in 100 cities there, but only the new species and new records where I have got it, I have presented over here. And then it is estimated to be 2,500 species, as our director sir expressed rightly in inaugural address. In that, the Phytophagous white grubs will be 1,500 to 1,700 species, and we have in our collection nearly 250 species, and 27 species I have described, and 12 species are there in pipeline I have to describe, and new distributional records nearly 78. So the diversity studies are very important for the documentation purpose, and also another thing, in this era of fast extinction of the species, we need to discover the species before it goes extinct. So lot many taxonomists have to come, lot many workers have to come, and lot many students have to get motivated to take up the taxonomy as their passion. It is not like earlier. Earlier taxonomy means it's like a jargon, because we need to think that getting a publication in taxonomy is very difficult, the study takes a long time, like that and all. But now everything is in place. That time the technology is also not that good. We have good number of microscopes now, good number of softwares now, and international support is there for us. International collaborators are there. They are open to us to give us the right inputs and also support, and referral collections are there, and libraries are digitized. So now most of the students should get encouraged and motivated to take up taxonomy as one of their subjects. Okay. So here I have given this table just to show that which are the very hotspot areas for discovery of new species and new records. So this is my papers that have been published. And earlier, Mustaq Ali sir, who worked vividly from GKVK, and also Veeresh sir, all respects to them, who have initiated the white grub work in UAHS campus, GKVK, and rightly supported by Viraktamar sir. They have done a lot of good work, and also A.R.V. Kumar sir, now Prakash is there, all of them with a good team, they are working on the white grub funnel diversity and also dynamics and also management. So Mustaq Ali sir in 2001, he has referred that 20 species belonging to 10 genera are the predominant on crops. But with my studies and also collections, I can make nearly 40 predominant species, because in Himachal it is a different one. And interestingly, just to quote here, potato, in Himachal Pradesh, potato is the main crop. There, the scarab faunal diversity associated with potato in Himachal Pradesh is very different from the fauna that is associated with the same potato for seed production in Ooty. So the scarab fauna is different. So like that, now the candidates are emerging as a tough and dominant species. Maybe they must be distributing. You take this area, you rule. I'll take this area, I'll rule. That's how they are becoming very predominant and also very tough candidates to manage. So that's how now I could find nearly 40 species that are dominant under 18 genera. That is potato example I have given. Just to quote this groundnut ecosystem. See, in Andhra Pradesh also groundnut is a major growing area, Rajasthan, Gujarat. Here the species is different, and the predominant ones are again different. Though the common ones are also there sharing, but species, region specific species are also there. And of late, earlier, we used to think that adult scarab beetles are only feeding on the neem trees, avenue trees, like that and all. But now they have turned as a pest to several crops, especially horticultural crops. Recently, I got a call from Bettamugilalam, Krishnagiri district from Tamil Nadu, stating that, Madam, beetles bantu, they are just feeding on our French bean. Then we went there. To our surprise, it is holotricha. Holotricha beetles just feeding like anything on the flowers and tender buds, pods, and there is a lot of fruit drop and the flower drop. So that's how they are turning as a major pest on several crops now. And beady leaf, Adorita species in Jhansi area, it is becoming a major pest in beady leaf, which is at the stake of the small workers who are depending on the beady industry. So that is the damage that is caused. So in nutshell, the diversity varies with the latitude, altitude, vegetation, crop, ecosystem, and with all soil types. So we need to give awareness to several farmers and also stakeholders about the coprophagus and the phytophagus, how we can differentiate. See, all the larvae also look same. Larva also, all coprophagus larva, the scarab larva, and within the phytophagus white grubs, all larvae look alike. So the minimum characters, I am also working on larval taxonomy now, and will be coming out with the diagnostic characters for at least predominant species, and this is also very important, and we need to give the awareness for several farmers. So I thank the Entomology Club and Kaleshwar Swami for giving me this opportunity to present few of my thoughts and ideas about this one. Thank you so much. Thank you. Any questions or queries? Something about the beetles feeding on the crops. Yes, sir. Sir, it is feeding on mulberry, it is feeding on kiwi fruits. Recently, I heard that it is becoming major on pear and plum in Northeast Asia. My question is, how does it differ from, for example, this this ash beetle? Ash beetle, sir? Cutting. Sir, actually, ash beetles will not, as far as I notice, ash beetles will not skeletonize, I think, sir. They come from the edges and they carve it out and they eat a certain portion of leaf lamina. But these white grubs, they skeletonize, sir. They completely away the laminar portion. Only the midrib will be remaining. So skeletonization can be very evident in case of white grub adult beetle damage.
Such damage in certain as far as this armorworm is concerned.
Sir?
Armorworm is concerned. Armorworm does the same test. They remove the midrib and take eat away all the laminar veneers.
Yes.
That is the case with both pests are there. So how can we differentiate?
Okay, beetle damage. Armyworm also skeletonizes. In that cases, we need to look for the pest. We need to look for the presence of the pest. Yeah.
How to differentiate the beneficiary and harmful?
Yeah. Larva, you mean to say, are larva, actually larva have a hump-like appearance for the coprophagous, dung rollers. Whereas, that's why I have kept it here. See, if you see, the second one is the dung roller. So you can see the hump-like projection in the anterior segments. So that is evident in dung rollers. Whereas in white grub, it is smooth, round curve. The first one is white grub. The second one is dung roller. So like that we can differentiate externally, but still there are other characters also like anal slit, palladia, all those things are also there. But as soon as you take, if it is a deformed shape, it is dung roller. And setonins I was telling, setonin is a humus feeder, and this bottom second one down is the setonin beetle. And that setonin beetle will not run on its leg or will not walk like this. It crawls on its back. So as soon as you put all larvae together, if you see larva crawling on its back, it is a setonin beetle. Okay, these are the small tips just to distinguish.
Madam, how would the extent of crop loss by these adult beetles, will it be so heavy?
Sir, not so heavy like larva.
Field crops like sorghum, then
Yes, sir.
and other crops.
Yes, sir. Not so heavy, but anywhere between 20 to 30% it will be there, sir. Nowadays it is increasing. And mulberry, it is so much damaging this holotrachea beetle. We are getting samples and also queries from mulberry.
Will it be so heavy in the absence of neem trees and other trees surrounding the crop fields?
Maybe, sir. Maybe. I feel the feeding behavior itself changed, these adult beetles. Nowadays they are turning into the mango. Mango also I saw, sir, in Assam, Sorbag I went. There one Lepidiota albistigma species is there. There it is feeding on mango leaves so much. So like that it is. Popular plant also. Yes, sir. Yes, sir. Host plants, adult beetles. Maybe they have developed a flair for the crop plants now. Because of late we are seeing more adult beetles emerging, and earlier what we used to think, okay, manage them with neem tree, the avenity as sir is telling, poplar tree, caged tree, all those things will be there. Spot spraying if we do, the beetles will come down. Now they are shifting to the horticultural crops and vegetable crops. Monocropping, yeah. Yes, they have to survive, that's what. Yes, true. Yeah, I hope.
Madam, what is the population or diversity of the dung rollers? Now the cattle are very.
Yeah.
You can say that in the sense.
Yeah.
The population what we are seeing in 1990s. So we are not finding anywhere.
Dung rollers?
Yeah, dung rollers.
No, we are getting. Maybe less would have come, but in our collection, light drop collection when we make, we are getting the dung beetles.
So now cattle is drastically decreasing in village side. So what is the alternate food for the dung roller now? Any idea?
No, not much, but humus organic matter, little bit they will thrive, but they need dung. They are going to roll, and the breeding takes place in the dung only. So they need.
Very good observation. That needs to be documented. How many there will be shifting?
That's what that's what he was asking. Cattle are decreasing now. No, I think they are diverting to open defecation by human, because I got.
That also decreasing, madam.
Yeah, I got samples from Kerala, and they were telling that this is from human feces. That is a dung beetle Anthophagous species. Yeah, but I think nature is very beautiful. They will find the alternatives. Some thriving. This thing. Yeah, exactly. I'm not working much on the dung beetle diversity. As of now, I'm concentrating only in the phytophagous one, white grubs. Yeah, I hope it's done. Thank you very much. Thanks a lot for your patient listening. Thank you.
No, we have many more questions, but no, you can contact Madam in NBR any time. Okay, so take the opportunity to thank her for coming over all the way from Bangalore yesterday, traveled, and now was there, and now talk about one of the most important group of insects. I thank very much from the bottom of my heart, as well as from Entomology Club on my own behalf. I'll be very thankful. Please come. I request Vasunagala sir to.
Thank you.
So from white grubs, I will switch over to termites. In fact, so I thought of finishing termites first and then white grubs, but no, Madam had to depart. So no, it was actually arranged in such a way that she will give the first talk and she will actually move. So I'll start with my area of specialization of termite taxonomy. So I'll be restricting the present status of termite taxonomy in India. Yeah, so in fact, our students, when we were actually planning this seminar, they were very happy to go and perform puja for a termite mound nearby. So they wanted this seminar to be successfully organized and finished. Be thankful to them. So and I was searching, I could able to get one interesting thing that Australians actually, if somebody has actually put cloths outside, they'll carry those cloths and place on the termite mound. So it actually looks very funny, but and then I started digging the information and I could able to learn that they actually do this if they perform this action. So the person who actually, the cloth belongs to that particular person means he will actually fall sick. something will happen to that person. I don't know. I thought it is we Indians have got this type of thinking, but even Australians have got this. And we should remember this man, David Attenborough. In fact, he crawls through the termite mound, get inside the termite mound, and he explains the activity of termites. And he was the person actually made these termites world famous, because he explained all the activities, and it was so interesting, and it was be able to understand to the common person. So that's the David Attenborough. We should remember whenever we talk about the diversity of insects. So in fact, my talk will be restricting to who actually the scientists who contributed to termite taxonomy in India, what actually we are doing in our lab, and what are the gaps. In fact, 100 theses can be submitted on termites. Okay, so there are hundreds of Amina, Kaleshwar Swami, like Runva, so many people has to work on these wonderful creatures. So whatever we are doing is actually less than 1% of what needs to be understood. So it will become incomplete if we don't remember this man, Runwal. I'm unable to use this properly. Yeah, Runwal was actually the director of Zoological Survey of India, who was actually the person who started the taxonomic work in India, and is a student, Kumar Krishna. He was actually research assistant under Runwal, but then he moved to University of Minnesota under Dr. Emerson. You must be knowing termite taxonomy, you know him as a after the scientific name, he put the authority name Emerson. So under whom he actually worked on for his PhD, and he actually became a world authority of termites. Okay, so he has published so many new species. Of course, I have given the article of Angel and Grimaldi, wherein he has listed more than 100 species, or I think 70 species of termites, which were actually described by Kumar Krishna. And these are the Bibles for any termitologists or termite taxonomists to start with. So the different keys have been given, especially for soldiers. Both are actually published by Runwal, as I was mentioning. And these are the 7 publications, 7 treatises of Kumar Krishna. So in fact, he has listed the valid name of all the 3,000 species which have been described around the world. And the valid name, what are the invalid, the names will become invalid when they are actually synonymized, and many other things. And they are actually freely downloadable. Both ZSI publication and these treatises are actually freely available. You can now have a look of these things. And just for out of subject, as many teachers are actually teaching fundamentals of entomology and other subjects. So if you, we were actually teaching IMS classification so far, right? So many of us may be still teaching IMS classification, but now we actually adopted around maybe just 5 to 10 years back. We switched over to Christensen classification, wherein actually we because of advent of molecular biology, lot of changes actually took place, and as a result we are adopting Christensen classification. I think if you glance through this classification, you will not find the Isoptera order. Okay, so nowhere you will find the Isoptera. The reason being, Isoptera has been merged into Platodia. So that is the reason, in fact. So there is no order called Isoptera now. So that one should keep in mind. It's merged with Platodia, cockroaches. Okay, sir. I'll just give brief information about why they are actually merged with Platodia. So in fact, before 1930, when Emerson was actually working on termites, he was actually had a idea that termites are actually the social cockroaches. They should not be considered a separate order in the year 1930, in those years itself. But it took many years to give a correct justification and prove that termites are actually the cockroaches. So it took around 70-80 years. And in the year 2007, this Inward actually published a wonderful paper called Death of an Order. Okay, so he killed the name Isoptera. So as a result of that, he actually gave a lot of substantiation for that. He actually sequenced number of genes and phylogeny has been analyzed, and they are able to prove that termites are actually the cockroaches. As a result of that, the Isoptera has been shifted to Blattodea. So the few other important reasons are the behavioral, ecological, and molecular similarities. So I'll just give some information about these. So one species called Cryptocercus darwini, which are actually the cockroaches which lives in a colony, and they'll actually they'll actually provide care for young ones, and they have got similar habitat, like the same type of food they eat, like termites. And another important thing is, as I was mentioning, genetic similarity. Okay, so when termites are actually found within the termite group, when they are nests within the termite group, cockroach group, it is not possible for anybody to consider them as a separate group. Okay, so maybe this slide will explain. You see here, termites are found within the other cockroach group. So if they are placed at the end, say for example, if the termitidae, what is mentioned, if they are placed at the end, probably they could have been considered as a separate order only. So, but they are found within that family, within that group, within that nest. So as a result, no way they can be considered as a separate group. So as a result, they were actually merged. So for teachers especially, so we regularly use these order names synonymously, like Dictyoptera, it should be superorder, which includes cockroaches, termites, and mantids. Blattodea, which includes cockroaches and termites. So if you use only Blattaria, it is cockroaches, true cockroaches. So our Blattodea includes both cockroaches and termites now. So the important group of insects, because of that, the termites were actually placed inside was this species, Cryptocercus darwini, which belongs to family called Cryptocercidae, which is a cockroach, which is a social cockroach which lives in groups and care for the young ones, and they also wash the symbionts inside the midgut like the termites wash. As a result of that, they found a lot of similarity between both termites and cockroaches, especially this group. That means, so probably this cockroach group has given rise to termites. So as a result, the termites were actually placed inside the cockroaches. So now we have you can use either infraorder Isoptera, down the order Isoptera, infraorder, or above the family, epifamily, Termitoidae. So we will not use the word family or order. Okay, so as a result of this modification, Termitoidae, okay, all the family ranks are retained. So we will not change the Termitidae, Rhinotermitidae, Calotermitidae, names have not been changed because it is downgraded. So in order to retain, so in order to avoid the confusion, the names of families are actually retained. So this is the modification, one important modification which everybody has to adopt, and termatologists have accepted this modification. So as far as the present classification is considered, so we have two groups. One is called basal family and the higher termites. The lower termites consist of Mastotermitidae, Odotermitidae, Archotermopsidae, Stolotermitidae, and Calotermitidae. These are actually the lower termites, and these are higher termites. So which includes the highly diverse group Termitidae, which includes Odontotums group and all. So what is the major difference is that they have protists or flagellates for digestion in the midgut, whereas the Neoisoptera, the higher families consist of bacteria or fungus for digestion. There will not be any protozoa. They are mainly wood feeding, whereas the Neoisoptera, the higher family, actually feed on wood, humus, grass, leaves, roots. So as a result, they are actually very important group. So in the basal families, there are a group called pseudargates. That means the nymphs actually have the capacity to develop into reproductives, which is not possible in Isoptera, Neoisoptera, the higher groups. So when it comes to the number, there are nine families, and within these 9 families, around 3,000 species have been described worldwide. So in India, we have around 297, including our species. I think I have not added Minas, around 10 species. It crosses, I think, around 305 now in India. Okay, so if you see the diversity, the Termitidae is actually highly diverse with 34 genera and 210 species, which includes Odontotermus or mound building species. Okay, so total around 300 species now. So, and the general information, I think all of you know this information, but in any termite mound, generally we will expect reproductives, one king and queen, and there will be additionally secondary reproductives. If anything happens to the primary king and queen, additionally secondary reproductives will develop. They are actually called neotenics. Okay, so and there will be workers and soldiers. So anyhow, whatever the egg laid by the queen, they'll hatch into young nymphs, and they'll become older nymphs, and few of them will become workers and soldiers, and naturally they'll reach to reproductive nymphs, few of the nymphs, and only during the swarming period. So it actually varies from place to place or the season of the year, and the emergence actually varies. Okay, so that's how the colony actually runs. And when it comes to taxonomy as such, we'll use the soldiers for identification. Now, whatever the keys the previous scientists have developed, it is very difficult to identify termites based on workers or the other casts. Okay, so we'll use the soldiers casts for identification. So in fact, the soldiers have got highly variable or modified structures, especially head and mandible structures, as well as the moderately fixed number of antennae across different regions. As a result, the soldiers actually gives a very important characters for identification. So various characters we'll use. Of course, I will not get into the details. And mostly the identification is based on measurements. Okay, we need to measure the head length, pronotum length, postamentum length, number of antennal segments, like that. So these are the suits, okay, which are actually looks very beautiful. And these are the mandibulate soldiers. And you can see I put only few of the photographs. And these are variation you will find across different group of insects, in the head especially and the mandibles. Okay, so you have to sit with microscope and measure the different lengths, and we will come to the conclusion which genera it belongs to, which family or which species it belongs to, like that. So what is the problem with identification? Okay, so I can train anybody who is interested in taxonomy in 3 to 5 days, but whether it is correct, 100% correct or is not, is actually God knows, because there is some problem with that needs to be identified, and future workers can concentrate on those lines. Okay, so some species lives within the nest of other species. So when as we are relying on only the soldiers, if something happens, if the collector or for example, naturally 2 species are found within the single nest. As you know, you'll be talking about termitophiles. Okay, 2 species are there inside means it is very difficult. So which one we have actually caught, which is that we have identified is a problem. So difficulty in associating with the different castes. Once they emerge from the nest, you might have seen the adult emergence in large number. So workers will be waiting in the emergent, the place where they are emerging, and the large number of swarms actually emerge. So once they come out, that you will not be able to identify, because there is not much good keys for identifying the imagos. So that is the problem. So otherwise, if you need to go there and monitor the emergence, and we need to collect all the castes, and we need to associate that. Okay, but even then it is actually difficult. So most species complexes are close related species. I will touch upon that. So literature available actually creates confusion for imagos. So depends on morphometric data. Many times if somebody sends 1 or 2 specimens, it's very difficult to zero out which species it is. Okay, we need at least 5-10 number of individuals. Okay, so whatever the keys are there, they are actually fairly, if you have got a good experience, you can identify imagos only to family level. Workers again only to family level. If soldiers are there, you can identify to species level based on the key. Okay, so but the problem I was listing few of the problems. You see here one of the problem, overlapping characters. For example, if you have 1 specimen or 2 specimens, and your measurement actually comes to 0.69 or 0.68. For example, here you see the species, for example, we will say that is Odontoderm redemani, has 0.69 to 0.79. It actually goes to redemani. Whereas the other species called obesus, the index actually mandible length and head length, it is actually 0.9 to 0.59 to 0.68. For example, one species we have measured, one individual we have measured as 0.68, another is 0.69. Unless we have the background information of ecological knowledge, it is very difficult to say which is that. So we cannot say we will just put on Odontoderms and we will send the information. That is the problem. Okay, so and another thing is that you see here, you must be knowing one important group of insects, Annacanthoterms, they are actually very big. They measure about 1.5 centimeter or so. They are actually freely foraging. All the termites actually they make galleries and they move. But this one actually moves like ant. It's an open forager. And you see here, there is a 1, 2, 3 species are there in Indian subcontinent. You see here, this is another same type of information I am trying to give. So here you see the mandible length and head length through base of mandibles 0.66 to 0.76. Okay, so So here you see the same information, 0.53 to 0.66. It starts from 0.66. Okay, so now also we will have the problem. Which one will actually place it? Okay, so from where they are actually collected, whether two different species, another thing is there is a possibility of disjunct distribution. You must be knowing about disjunct distribution. When two related species or a single species lives in two different places, when there is no, even though there is no geographical barrier. We have a species called Microceratops pakistanicus, which lives in Pakistan and only in Western Ghats of India. If you key out that, it will go to Microceratops pakistanicus. Okay, so unless and until we have a lot of other information, including molecular information, it is very difficult to say that it is actually pakistanicus. Yeah, so difficulty in associating, as I was mentioning, that once they emerge from the colony, it is very difficult to say whether it is actually UAHS or whatever. Okay, so we need to collect all the casts there itself, and we can say that this is actually the exact species. So hence, the possible help we can obtain is through DNA barcoding. So now barcoding actually provides a lot of additional information in order to support the morphological information, but it is not a completely different thing. Whatever there is the additional thing which we can depend on. So morphological identification is must. Okay, so only thing is that we need to barcode all the Indian species or all the world species, and we can develop a library. So this is the sequence of this particular species. Not a single gene. We need to depend on more number of genes. So if we have the barcode or the library available, so if somebody else sequence it, and you can just say that this is actually this species. That is the second thing one can do. So the problem is that now we have in India around only 40 barcodes. Around as we know that now in India around 300 species are there. Okay, so we have barcode only for around 70 species, less than 70 species. In my lab we have barcoded around 40 species. So we need to reach to all the 300, and we need to barcode all the 300 species. Then if you develop the library of that one, so then we can say that this is actually particular species. We will not have that problem of UAHS, red money, if the measurement overlaps, and all that problem can be avoided in the future. But the problem is that you should have more number of genes, not just we usually depend on MTCO1, MTCO2, S16 or S12. I think Meghana is there, she is actually whatever the specimen we give it, or in the morphological identified, she will actually identify to particular species from molecular barcoding. So what actually we are doing is actually through DST Young Scientist project of mine in the previously funded by DST, and now with the MOEF funded project. So we are actually collecting from South India. So previously I was concentrating on Western Ghats. Now actually throughout South India we are traveling and collecting, and we have deposited around 80 species in my laboratory. So our target should be 300. Okay. So and barcoded around 40. So at least whatever the species which we have collected should be barcoded. That's actually our ultimate target. And more number of genes, as I was mentioning, just not MTC1 or 16S RNA. So we will actually trying to do other genes as well, so that if any problem arises when you are comparing, so that problem can be avoided. Okay, so that's our target. So as we know that less than 70 species throughout India are actually barcoded. But another problem is that so many molecular biologists, what they have done, so they will take the specimen, they will actually sequence it and wrongly says that this is actually particular species. For example, many species are actually uploaded to NCBI wrongly, saying that this is a particular species. But if you refer the literature, those species are not being reported from India only. So many Taiwanese species are deposited from Indian scientists. Okay, so that's why so morphological identification is must first. Okay, so then if it is confirmed by a taxonomist saying that this is a particular species, then a person can upload it. So if it is wrongly uploaded, if somebody else will actually barcode it and wrongly again it matches with the previous library, the problems will get accentuated and continues. This problem will actually goes on happening. So this problem should be avoided. Okay, so and we do identification service. Whatever the scholars and the students comes will be trained as well. If they send the specimen, we will be identifying. So as such, I request if anybody wants to learn, they are welcome. At the same time, if you are sending the specimen, try to collect as many soldiers as possible, including workers. Okay, we will try. If their samples are fresh, we will also try to do barcode. Okay, so based on our experience, we actually published 2 species. One is actually Neoterms Viraktamate. Viraktamati is actually, Viraktamate sir was actually the first person to put me to work on termite taxonomy when I was working with the NPIB project, Network Project on Insect-Based Systematic. In fact, so many people like me were actually trained. Yashwant is there. Okay, so many students were actually trained during that time. And so now we are actually placed in different parts of India, and we are working on different groups of insects. And that information was actually published in Oriental Insects. The second one was Silonitermus terminalis sayadriensis. This was collected by my student Ranjit from Kerala, and we named it as now as this was actually collected from sayadriels. So this is the second species which we published in Journal of Asia Pacific Entomology. So then now in fact we also did a lot of diversity analysis because Shivamogga actually provides a lot of opportunity to study the habitat disturbance. Okay, so to check is there any human or anthropogenic disturbance on the diversity of insects, especially termites. So in fact we choose different areas and compare what is the diversity. So we did a lot of experiments. I am just trying to put 1 or 2 experimental information. So in one of the experiments we choose, in Shivamogga district we choose Maidan region, semi-Malnad, evergreen forest, because for in Shivamogga you will feel that we are in Malnad. It is not as such actually. So if you move towards east, there is a Maidan region. So Shivamogga as such is actually semi-Malnad region. If you travel around 10-15 kilometers, you will actually get the Malnad region, the Western Ghats, the rainforest region. So this actually provides very good opportunity to study the variation in anthropogenic disturbance or the farming activity on the termite diversity. Yeah, also in fact we did with another set of experiment with by selecting different types of ecosystem. So this is the explanation about different ecosystem which we choose. I think this is self-explanatory. If I say that Maidan region, semi-Malnad and evergreen, I think all of you will understand. And we did the standard transit method of sampling in order to sample termites, and we started identifying the termites. And if you look at the number of species which we collected in rainforest, which is around 18 species, for about 2 years we collected continuously. Every month we used to collect whatever the termites which we get, and we used to identify. These are the different species which we got from rainforest, about 18 species, 14 in semi-Malnad and 9 in Maidan region. Okay, so that indicates that rainforest actually supports large number of species, but the reason being, so many of the termites are actually involved in decomposition process. They are actually the litter feeders. Okay, so but in agricultural ecosystem now, especially the cropping ecosystem, we will generally find the Odontotermus and the other wood feeding insects. Okay, so diversity get affected because of the human activity. So that is a good indicator that if you preserve the forest, definitely there will be a possibility of preserving more number of insects, including termites. So in fact you can see here 6 were exclusively recorded in Western Ghats, rainforest area. So we did our diversity analysis experiments and all. I will just skip many of these information. That is a self-explanatory say. I am just trying to say that so disturbed habitats will have the less number of species compared to the undisturbed habitats. So the information was actually published in one of the journals called Journal of Entomological Science. And I am proud to say that we actually put Shivamogga in the title itself. So and we also did nutritional analysis of termites by collecting the imagos in large number. We require around half a kg of termites in order to do the nutritional experiments like what is the protein composition, fat composition, lipid other mineral composition and all. So around 50 to 60% of protein is actually present in imagos. So I was reading somewhere that if we eat one termite queen, we need not eat for 2 days. So that much of calorie will obtain. So they are actually very good protein source. So only thing is that only as we know, traditionally we eat termites, the queen and as well as the imagos. But only thing is that has to be popularized. So anyhow now United Nations is actually trying to popularize, funding a lot of projects for those who are interested in research on insects as human food. So now we are actually trying to produce any of the dishes from termites. We are actually planning to do that. And this is the list of the barcodes which we have submitted from our lab. List goes on. You can see here, we have mostly we have actually now sequenced 16S RNA gene. So that is mostly useful for phylogenetic study, but it is not a good marker for identification as such. Okay, it's very difficult to sequence MTCO1 and MTCO2. Those are actually the comparatively good marker genes for identification. Okay, so there is a problem with the techniques we are actually using. So anyhow, so now we are collaborating with John Sabatnik. I was telling about Czech University Life Science scientist who visited our lab. He is actually giving a lot of inputs so that we ourselves, they have got a good techniques in order to extract MTCO1 or MTCO2 from termites. So there is a problem with that needs to be correctly addressed so that we will actually barcode all the Indian species. So I just move out what are the species which we have actually sequenced. So like that we have actually sequenced around 40 species of termites. So I'm just boiled and few of the species like Coptotermus gestri, Coptotermus sajoti and testaceous, which are actually not there in India. So myself and INR and DPPQS people actually published one paper. So in the would we import, so termites may also enter. Okay, so if our quarantine system is not strong, okay, definitely there is a possibility of invasive termites entering to India. We have not just fall arboretum thrips and so many other species are entering and causing huge losses to Indian agriculture. So as we are already facing the problem in urban system, the termites may also enter and cause serious losses. So they were actually intercepted, but we do not know whether all the products which we import, if few of the individuals enter our place, India, so there is a possibility of build up of the population and cause huge problem in India. So the DPPQ was actually every month gives the non-compliance report. Non-compliance report means if they are actually not subject properly, the important country, the country from where they are actually exported. So if you receive the information, the products in not a good condition, or if they have got any insects, they will actually put in non-compliance report. The INRs actually will elaborate on this, and they will actually list this type of information in their website, like intercepted Coptotermus species like that. Okay, so all along we will be talking about many other insects, but now we are also talking about the invasive termites. Okay, so because now wood is actually a very important good, we are actually importing since recent years. Okay, so around 28 species have been reported to are actually reported as invasive species. So, and one species called Coptotermus gestri, which was actually reported in India long back, around 60-70 years back, which has not been reported again, not been collected again, but that is considered as a very serious pest in other parts of the world. Okay, so many species which are there in, so just I will try to quote, there is a species called Mastrotermus darwiniensis, which is there in Australia, now moved to many other parts and causing losses, like Nasiutermus carnigel, which was actually basically from South America, has moved to other continents and causing losses. So we should be careful looking into the experience of other countries. So we should be very careful in quarantine system and try restrict any entry of invasive species. So I will not get into the details of all these things, because all those 28 species have moved from their original habitat and causing serious losses in other parts of the world. In fact, we also intercepted, and two of the publications are published, like first interception of two feeding the potential invasive termites in International Journal of Tropical Insect Science, and recently we published one same interception in Current Science with NBIR scientists. So, and then very recently I wrote one review paper wherein actually I detailed what should be our procedure and what is the possibility of entry of these invasive termite species, and also importance of integrative taxonomy. Integrative taxonomy means we combine all the taxonomic knowledge available, and we will try to use them in termite taxonomy, because we are actually relying on morphological taxonomy. Wherever that problem is there, that needs to be identified and used. Okay, so they are beneficial or harmful. All the time we say Geddalu means are actually harmful. Okay, but lot many are actually highly beneficial. So if they are there in forest ecosystem, they are actually very useful insects. Okay, if there is no termites, imagine that whatever the wooden log or whatever the litter which actually falls get accumulated and cause lot of problems. So these are the first group of insects which actually enter, and then they'll actually start feeding, chewing, and as a result other microbes enter and they hasten the process of decomposition. Okay, so only in the urban ecosystem will have the problem, but in the farmer's field also there may be problem. But previous reporters from India, G.K. Viresh, D. Rajgopal, Ashok Kumar sir, few of them actually reported in Karnataka, in Bangalore, they reported that they are considered as a pest in cropping fields. But in one of the important study, you can see here ants and termites increase crop yields in dry climate. In that, they are published in Nature Communications, and they say that around 36% increase in the crop yields because of ants and termite activity. So because of their seeding activity, foraging behavior, they increase whatever the residue is there, it should be decomposed and helpful in increasing the soil fertility. So we need to look into different directions and conduct few of the experiments and prove that whether they are really beneficial or harmful. Okay, so that's the one area one should look on. Okay, of course there are pests, and wherever there are pests, especially in urban ecosystem, we should have a completely different set of strategies in order to manage termites in our domestic condition. Okay, so if you look at the termites important groups, wherein they will find the pest group and the beneficial group. So most of the species belongs to family Rhinotermitidae and Calotermitidae especially. They are actually pests. Whatever the wardrobe and all the plywood eating termites actually belongs to Rhinotermitidae and Calotermitidae. So most of the very few species of Termitidae are pests, considered as pests. Okay. So but in farmers' field, so if they are unmanaged, if the gardens or the fields are unmanaged, so they may pose a problem. That's based on my experience. But so looking into the conditions, we should say that they are actually causing serious losses. Otherwise, most of the Termitidae, okay, so which is highly diversified group, so most of them are actually beneficial. And that's how the coptoterms especially and heteroterms cause this type of damage. So they don't leave anything, especially in urban ecosystem. So in economic damage caused by the termites in Indian urban system is huge but not calculated. Okay, we do not know how much actually the insecticide, the usage will actually use, and the amount of money we spend in managing those termites. So they don't leave anything. You can see the Dr. Prasad's Bharat Ratna was also eaten away. Okay, so if they are not taken care of, they are the one who comes and eats. Okay, so they may access terrorists sometime, because whatever the documents, if they are not taken care of, they are simply kept somewhere and left. So they are the one who comes and silently invade and cause damage. Okay, so but overall, if you look at the ecosystem as such, they are actually very beneficial group of insects. So only thing, they have to be monitored properly and used for human well-being. And wherever they are actually pests, especially you can see here in Africa, where a lot of work is done, their diversity is very rich. So wherever termite mounds are there, we will say that they are actually the hotspots of fertility or the nutrient patches. They will actually support many other organisms. Okay, so that's how they are actually considered as very beneficial. But in India, so you can see a lot of information is virtually unknown. Okay, so that needs to be targeted. That needs to be studied. Okay, so wherever unmanaged fields or gardens are there, this is how they may cause the damage. So I will not consider them as serious pests. I'll feel that I am the supporters of termite. Okay, some problem. Yeah. Some problem. Okay, so as I was mentioning previously, you can see here. So of course, around 5 to 6 liters of insecticide is actually placed in when we start as a pre-constructive measure. So after that, every year actually we may put at least 1 liter of termite, insecticide in each of us, our houses. So you can see, just imagine that goes to drainages or whatever, and ultimately it comes to us only. So of course there are a few measures. Previously PCI was there, which tried to develop some strategies or import some of the strategies to identify the termite activity in the houses. One technology called Termitrack, okay, which was there. If you place that equipment, it's actually used to detect the movement of termites inside the walls. Okay, so but PCI is actually closed its activity mostly. I think Dr. Baira is there and another UPL person is there. Probably they can add some information with respect to the industry involvement in management of termites. Of course, there is as I was mentioning, that more than 100 theses can be submitted on termites. So I'm just opening few of the areas one can think of to work on termites. So only when it comes to identification, the taxonomy, we are just identifying and saying that this is the species, and we are not getting into the beta or the alpha level taxonomy. That means we have not understood the phylogeny or the evolution of termites. Okay, there is a lot of scope for that, and so most of the foreigners are actually working on higher taxonomy. One can collaborate and work. And foraging ecology and chemical ecology, of course. Foraging ecology, previously our now UAHS, Bengaluru entomology department, lot of work has been done. But chemical ecology, no. Okay, so a lot of work has to be done. Contribution to greenhouse gas emission. So overall in the worldwide, around 3% methane is actually emitted through termites. What is in India? So we need to curb the methane gas emission. Of course, I was telling that they are very beneficial, but there are ways and means to reduce the chance of increasing the methane gas emission through the termites. So termitophilous insects, actually we'll actually start working on this group of insects. Kannada is actually specialized. We have traveled at least around 20 countries so far. He's young, around 36-year-old, but traveled Africa, Southeast Asia, and collected termitophilous insects, especially rock beetles, and described around 30 species of rock beetles. Okay, so we'll start, and absolutely there is no information in India on termitophilous insects. So they are the inquilins which found inside the termite mounds. And termites gut microbiota, again, nothing. So invasive termites, actually we get to work on. Contribution of termites in increasing the crop yields, one can think of. Nutrient status and developing termite-based food. Termite-inspired buildings and structure. You know that there is only one building in Zimbabwe, Harare, so where the Mike Pierce actually constructed a wonderful building in 1990, and now it's still a model. And nobody else has exploited that technique in order to build such buildings which actually completely air-conditioned without air conditioner, without use of electricity. So termite management in urban landscape, it is actually opens up a new area for anybody other than the insecticides. So if anybody interested, they can come to my lab and learn the taxonomy. And if you are interested to send the specimens as such, so collect in 70% alcohol, put the label, try to collect as many termites as possible, including both soldiers and workers, and send for identification. Usually they are preserved wet like this. They should not be preserved dry like any other insect you do. So in fact, since last 10 years, so many students, at least 4 to 5, Santrupti is there here, around 4 to 5 MSc students and 3 PhD students have completed, and one of my students actually got ICR best thesis, ICR Jawaharlal Nehru Award for her work on termite taxonomy. So she's the one, Vijayashree, Pavitra, Adarsha, Kavita. I should not miss their name before ending, because they go out and collect lot of termites and bring them for identification. Pavitra, Santrupti, Yuvraj, Karthik, and whatever the specimen we bring, Meghana will barcode, and she says that this is actually belong to this species. So thank you. If there are any queries, please. Yeah, published. Well, we have just placed them outside, sir, here only. So please, except Santrupti.
Many times, we understand that green ply and then century plywood, they are termite proof and all. Yeah. They say that it protects from termites for several decades.
Yes, sir. Is really so. Rashmi will come. Okay, she will answer to you. So I am also looking for that, sir.
In your project, you have collected the termite from Gadag, Dharwad, where the blocks are deep blocks.
Yes, sir. So mostly odontodons. Mostly odontodons, because I have the details of all the species and collection localities and the distribution maps of throughout South India, and especially concentrated on Western Ghats.
Only subterranean,
No, mound building are there. Few of them. Obesus is there.
In black soil, I never found the termite mound.
Okay, okay.
Because there is a lot of cracking during the summer.
Okay.
I never find the termite mound.
No, Obesus is there everywhere. No, even in Dharwad and in Hubli, Gadag.
Because of deep black soil.
Obesus is there everywhere. But in Western Ghats, you will find a lot of Nasuti terms. Okay, Pericapri terms, there are other groups. Yes, sir. It's around 55 to 60%. Yes, sir. 3 species actually we did, Coptoterms heavy, Obesus, and Microterms obesi. So it's around 50 to 60%. So it actually supports anybody's meal. So only thing is that that needs to be encouraged. Make it as an attractive dish and provide.
So other than chlorpyrifos, any chemicals?
Yes, sir. There are 4 or 5 which are actually registered against termites. One is chlorpyrifos, as you said, bifenthrin, widely used, imidacloprid, and chlorantraniliprole. Okay, which are widely used in especially in urban system, domestic condition.
Maybe in the world they have insectary to mass multiply this.
Yes, a very good question. In fact, there was the thought of the important problem we'll encounter in order to understand the biology of termites is it's very difficult to rear. There is only one lab in fact, Jake, they have tried, but in US, in Florida, one person called Chowenk, okay, so who is actually rearing Coptotermus formosanus, which is a very devastating and serious pest. They are trying, and we need to maintain that condition. Okay, so Baira has got some idea, sir. He was there at Jek University of Life Science, and it is very tough. So I think we need to have around 5 to 8 people dedicated entirely to provide that condition and also maintain them, because they are actually social insects, and we need to provide all that conditions which are prevailing. It needs to be.
I think Vietnam, they have standardized these crickets.
Yes, sir.
For food side.
Yes, sir.
Similarly, as you say, the protein content is so high, so it should be in.
Yes, sir. If you rear them, definitely it can be done. So only thing is that it is very difficult.
It's very tough, to arrive at a species count, because as you say, this is not only just the morphological characteristics.
Yes, sir. Yes, sir.
For the right species.
Yes, sir.
Then also the molecular level.
Yes,
Say the alpha and beta and gamma
not at all touched, sir.
So for the species identified is based on the alpha.
Morphological character.
It may be revised.
Yes, sir. Yes, sir.
later as
Yes,
soon
sir.
as you
Sir, around 60 species have been published from China, but there are only 27 are valid. That means all of them are actually, they'll say that they'll revise and they'll actually.
They are required to be revised.
Yes, sir, revise entire things. So the one paper say that revisiting the Coptotermus taxonomy, the same title is there, written by Chowenk and Gurbs. Yes, sir. So if you have the barcode of all the world termites, that's what our international group is actually trying to do. Okay, so collaborate with all the people and try to barcode all the species of world, and then we'll have the correct picture of phylogeny. Yeah.
Regarding the termites, very harmful.
Yes, sir.
So I do find actually termites like alone won't contribute to the plant growth, because
Yes.
having 55 to 60% of the clay.
Yeah.
So when this plant side will sweep the
Yeah.
inside, there will be.
Yes, sir, definitely. Activity as such, I told. So movement. Okay, so when they mix the surface soil with the about feet soil, so definitely there will be increased activity of microbiota as well, and then fertility increases.
And also in the termite plants, there will be no other organisms will be there in the plant itself, in the plant side.
Okay.
As you said, there will be support the other organisms.
Yeah. So that many, probably at least around 5 different groups of insects are there. One important group of insects on which Dr. Kano is working are row beetles. Yeah. So.
Any idea about the termite mold soil? Any beneficial aspects of the termite mold soil from Saturn?
Yes, sir. It's
people are using soaps, making toothpaste, tooth powder already, and they use
and people say that they are actually the place of gold mines. So wherever the termite mounds are there, there is a possibility of
tooth powder, which I use 20% of this.
Termite mounds.
It's working very well. It's going like almost every week I sell 15 bottles of it.
Oh.
In fact, some medicinal properties of that particular.
Yes, sir. Yes, sir. A lot of things have been worked out, sir. Only thing is that so we need to popularize, and that's what, sir. So probably discussions. By the end of the day, sir, we should say that termites are actually good rather than they are actually bad. So thank you. I will continue with the next speaker. So continuing Avinash's discussion, Avinash actually worked under Dr. N.G. Kumar sir. He also worked on termites. So I am happy that he has come, and he was. And continuing his question, so that Dr. Kano is actually is now, I can say, authority of row beetles. Termitophilus row beetles, the row beetles which survives inside the termite mound. Okay, so he's exclusively working on the Termitophilus beetles around the world. So as I was mentioning, he has traveled to many countries already, collecting row beetles inside the termite mound and describing them. So more than 25 new species of row beetles have been described by Taisuke Kanoi, who is from Yamagata University, Japan. So in fact, we have a termite research team which is actually found, has been identified in different areas of different universities, and we are trying to collaborate. And the first basic mandate of the termite research, it is an informal termite research team, and the basic mandate is to barcode all the termites. First thing. Second thing is the ecological information that needs to be generated. So Taisuke is actually working on Termitophilus row beetles, and he will be delivering the species diversity and the evolutionary history of Termitophilus row beetles. Thank you. I give it to you.
Okay, thank you for the introduction. Good afternoon, everyone. First of all, I'd like to express my thanks to Swami invited me to here. This is my honor to speak in front of you. So, before my talk, I would like to introduce by myself very briefly. Okay. So, I am now assistant professor. I got current position 2.5 years ago, so I'm still new teacher in the university. I got PhD 2015 in Kyushu University. Spent as a postdoc season in two localities in Kyoto University and voiced at Okinawa Prefecture in Japan. So my hobby is a kind of field work. I visited to many countries, but not 20, just more than 10 countries actually. So this is Kenya and this is Madagascar with the UAHS member. So in this talk, I'd like to share the basic knowledge about Termites insects, not only log beetle, but also other insects living in termite nests. I would like to start quite general introduction. The species diversity of insect is very, very high, More than 1 million species are known, described in the world so far. But in some paper, researchers say more than 80 million species exist in the world. Every insect has very interesting shapes, beautiful color, and fascinating morphology. Everything is very interesting for me. And the insects are living in everywhere except for the ultimate environment, like volcanic area or sea. The forest is one of the most species-rich environment for insects, of course. Grassland and seashore area are also, there are a lot of insects. Also, the insects have a variable relationship with other organisms like fungi, plant, and insects themselves, and microbiome, of course. Then, the termite, the important insect. As you already explained by Swami, probably when you hear the word termite, maybe you imagine the word decomposer, the pest, and social insect. The termite is currently known more than 3,000 species. The species diversity and biomass are rich in rainforest and savanna. The termite can eat decayed plant material. Some species have lichen, some species in soil called as final decomposer. Termite is also important for many other insects or animals. Maybe you know the biomass of termite is super high, so termites are targeted by many insects as a source resource, a food resource. The natural enemy is, I believe, ants. Also, the nest of termite can be the nest of other insects. Maybe you know the termite nest the temperature and the humidity inside of the termite nest are managed by termites themselves, and so it is very, very comfortable environment inside. So once the other insect get into the termite nest, the insect can live with termite very, very comfortably. Especially the colony was defended by soldier termites, so they are natural enemy-free environment and air conditioner, good condition, good environment. So I'm studying on the termitophiles. Termitophiles. It is non-termite insect living in termite nest. So the termitophilous insects are defined as insects associated with termites during at least one stage of their life cycle. These insects are known from 39 families of 12 insect orders. Actually, not so few. These are examples. Springtail, it is one of the most abundant termitophile in the termite nest, and silverfishes, flatbugs, flies, wasps, beetles. And the beetle is the most species-rich termitophile in insect. The association with termite are variable among the termitophilous insect, and the relationship can be categorized into the three groups. One of these are synectrons. It is a bit strange pronunciation, but these synectrons are persecuted guests, and they are adapted by termites. And these species are mostly predators of termites. These are example, true bug, scatter